In this part of the course, we'll be talking about evaluating rolled steel beams. Now again, as we've already mentioned, we can evaluate rolled steel beams using either allowable strength design or load and resistance factor design. In either case, the calculation of the nominal moment capacity, Mn, is the same. ASD takes the nominal moment capacity and divides it by a safety factor shown on this slide as omega, and the load and resistance factor design method takes the nominal moment capacity and multiplies it by a resistance factor, which is shown as the Greek letter phi on this particular slide. The design capacity in either one of these philosophies has to be greater than the required moment strength. For ASD, the required moment strength is MA. For LRFD, the required moment strength is MU. As far as both philosophies, ASD uses a safety factor, and for bending moment it will be 1.67. LRFD uses a resistance factor of 0.9. The nominal moment capacity is basically going to come out of a formula. What you need to do is you first determine what your unbraced length of your beam is. So the unbraced length of the compression flange is termed L sub B. You determine what that is for your particular problem. The second thing that you need to determine is what LP is. We've talked about this earlier, but LP is basically a dividing line between Category 1 and Category 2 type behavior. The third thing that you may need to calculate is LR. LR is again one of these dividing lines between different behaviors. LR is the dividing line between Category 2 and Category 3 type behavior. You're going to need to know what category you fall into because each category has its own formula for Mn. Category 1 is when your unbraced length is less than L sub P, less than or equal to. Category 2 is when your unbraced length is between L sub P and L sub R, and Category 3 is when your unbraced length is greater than L sub R. As far as the formulas go, you won't fall into Category 3 all that often, so I'll let you look up that formula in the book. But Category 1 and Category 2 are quite common. Category 1 is the plastic moment capacity, and its nominal moment strength is simply calculated as Zx times Fy. In Category 2, this is for inelastic lateral torsional buckling, and the formula for nominal moment capacity is as shown. The C sub B on the outside of the brackets in the Category 2 formula is called the bending coefficient. You can always take the bending coefficient to be 1. This is conservative when you do it, but it is commonly used.